Hello, welcome to the bootcamp. So after covering Excel and e-views in day one, then we move on to mathematical economics. And this first lecture is actually self-study, actually no lecture at all. Okay, and then the prescribed chapters are chapter one, the very basic mathematical concepts and methods, and then chapter two, economic applications, linear mathematics. Okay, so I rely on you to make a serious effort to do self-study in case you totally forgot all the basic math skills. Okay, so from my side, in this summary lecture, I will very quickly go through the slides. Okay, the very basic concepts. I think you should know these numbers and sets such as real numbers, non-real numbers, rational numbers, irrational numbers, fractions. You should know what fraction means. Integers, without decimals involved, but the numbers could be negative or positive, and the natural numbers must start from, I think, from one, actually only positive numbers. Okay, actually including zero, natural numbers. Okay, and then I've got examples on this slide. Very basic skills, primary school level mathematics. Okay, and then multiple operations, multiplication and divisions must be done first before addition and subtractions, unless brackets are involved. Again, very basic math eco knowledge. And then there are some examples. Negative numbers, okay. I think again, self-explanatory. And then you just need to be careful with regard to multiplication or even division if negative numbers are involved. Okay, fraction, you should know it is numerator and denominator. Okay, and then decimals here, and then for some decimals you can actually express them as fractions. Okay, and then there are a few examples on slide number 10. Percentages, okay, percentages can also be expressed as fractions or decimals. Okay, so please look at these examples. Prime numbers, okay, the definition is here, and then some examples, and then I ask you two questions. Why 4 and 10 are not prime numbers? So you must think of the answers. LCM, I hope you still remember what LCM stands for. If you think about LCM, then you would obviously think of another concept, which is HCF. Okay, so there is also an example here, and then two questions for you to do. Exponents, okay, this is the base, this is the power or exponent, okay. And then surds, okay. And then there are certain exponent rules. This is the first one. I hope you still remember it. This is the second rule, exponent rule. This is the third one, and then the fourth one. So you can actually see I already provide a lot of examples on the slides. Okay, two more. Just be careful with the last one if your exponent is negative. All right, okay, and then two more. These two rules involve surds actually. Okay, this is the special case. If the exponent is 0 actually, then x to the power of 0 actually gives you 1. Okay, monomial versus polynomial. Okay, and then some rules on simplification of fractions. Okay, so I can skip these slides, and we rather will focus on simplification of polynomials, such as adding the like terms together or subtracting the like terms. Okay, and then the unlike terms cannot be added or subtracted, and then there are some examples here. I think this is a good example, so let me stop for 10 seconds for you to go through the second example. All right, okay. Few more examples. This time it involves multiplication and division. So you can multiply the numbers together, and then for the exponents with the same base, look at the third example, you can do a bit of simplification. So look at the third and the fourth example, please. Okay, further examples. This time it involves fraction. The polynomial involves fraction. You must have a common denominator before you can add up the numerator terms together and then see if you can simplify further. Okay, expansion. So there are two examples here. Actually, this is just an off-topic comment for this bootcamp. I think Excel E-views are quite straightforward. And then starter, you have to practice with the starter commands. If you don't use starter for a few weeks, you will quickly forget how to use the software. The math eco topics are quite straightforward. You just have to practice. I rather think the most challenging topic would be econometrics because we are using a new textbook by Woodridge. So you would feel some gap in terms of the level of difficulty between Gujarati, your undergraduate textbook, and Woodridge. It will take a bit of time for you to get used to Woodridge. So when you use the Woodridge book at the beginning, you would feel a bit intimidated. But from my experience over the years, when it comes to the honors econometric students, initially they were a bit frightened by the Woodridge book, but at the end of the semester, they all perform okay. In fact, the honors econometrics has very high pass rate throughout the year. So I'm pretty confident the same thing is going to happen this year. Okay, one more slide on the expansion of polynomials. Okay, factorization. Okay, a squared plus bx plus c. If a is equal to 1, then the simplification is much easier. The factorization is much easier. So when you have time, please go through the examples. Okay, I'm not going to go through them here. It's self-explanatory. Rather, if a is not equal to 1, then the factorization would take a bit of time and effort. So look at these two examples. Okay, some special cases, 3 special cases. Then we move on to coordinates. I think these are the self-explanatory basics concepts. So I can skip this slide. Gradient, you should know how to work out the gradient. y2 minus y1 bracket, x2 minus x1 bracket. You need 2 pairs of coordinates. And then we can derive the equation of a straight line y equals mx plus c, your metric mass. Okay, and then there are a few examples, so I can skip these slides. And then interpretation of the gradient. Negative slope, positive slope, and this is the special case, constant function when slope equals 0. Then you can expect graphically it is a horizontal line. Okay, then functions, y as a function of x, and then some economic examples, price as a function of quantity. It means we simply rename y as p and we rename x as q. Similarly, total revenue is a function of quantity, meaning I rename y as tr, total revenue, and I rename x as q, the quantity. This is another example. Marks is a function of study hours. Okay, linear function versus nonlinear function. Okay. One thing you need to remember is that for the nonlinear function, the number of turning points is equal to degree minus 1. Degree stands for the highest exponent value. So in other words, for this one, degree equals 2, so expect 1 turning point. And then for this polynomial, degree equals 3, so there will be 2 turning points. Inverse function, okay, if I give you y as a function of x, can you derive the inverse function? X is a function of y. You just have to move the terms around until you have x on the left-hand side, 1x on the left-hand side. Okay, simultaneous equations, there are various methods to solve for x and y. So for simultaneous equations, we have to give you 2 equations, and both equations involve x and y. So this is the graphical sketch method. And then method 2, okay, equating to the same variable, and then there's an example here, self-explanatory. Third method, substitution. Again, there is an example here. Okay, and plenty of examples on your prescribed textbook. Method 4, row operations. Again, with examples on the slides and in the prescribed textbook. Then we move on to the quadratic equation, y equal ax squared plus bx plus c, and then I think this time y is equal to 0 actually. Then you have to solve for x. Okay. First method, graphical method. Second method, factorization. Third method, quadratic equation formula, but you need to remember this formula. I'm not going to give it to you. Again, all these are matric high school level mathematics. Okay, so that's it. And then in the study guide, okay, you see I didn't type much in the study guide, but then I give you some revision questions to do, okay? And then interestingly, for the last few revision questions, they are economic applications, okay? So this is an example, linear questions, linear mathematical economic problems on total revenue and total cost. And then this one, I give you the demand and supply equation, then you solve for equilibrium price and quantity. This one, okay, demand, supply, you solve for equilibrium price and quantity, and then I give you a price, ceiling, price floor, then you have to work out, I think it is shortage and surplus. And then at the bottom, I show you the graphical sketch, although in the question, I really didn't ask you to do a graphical sketch. So who knows? I could actually add 8.7 to ask you to do a graphical sketch. Then you see the demand supply curve, equilibrium price, equilibrium quantity, and then the shortage quantity and the surplus quantity. Okay, so that's the revision lecture self-study topic. Okay, then we will move on to differentiation in the next topic.